Hello again everyone, welcome back to ptet.chemistry channel. So this is part 2 of the series of lecture tutorials on chemical formula and equations. In the last lecture tutorials, we talk about common formula of elements, as well as common formula of some compounds that you're supposed to know in your syllabus. So these are all simple covalent molecules because these are all the molecular formula, which is the number as well as the type of different atoms in one single molecule. These are all covalent compound. And we also talk about some elements, especially the noble gases. They don't like to form any bond, so they just exist as monoatomic, as single atoms, whereas there are some other nonmetals they like to form covalent bonds with each other to give you this diatomic molecule, because they contain or consist of two atoms joined together, such as these N2O2H2, F2Cl2I2, and Br2. These are all group 17. These are N2O2 and H2. N2 and O2 are components of A, the A that you're breathing in. These are lower secondary signs. These are the noble gases that exist as single atoms. On to the next part, which is determining the valency of elements. So valency is basically, well, they say it's the charge value of the ions here. Actually, there's another definition for it. It's basically the combining power of the elements. So what actually happens there is, if you look at group 1, the group number represents the number of valence electrons. It tells you how many electrons are there in the valence or in the outermost shell. So these are number of valence or outermost shell electrons. Group 1 has one outer shell electrons, and of course group 1, 2, and 3, these are what you call metals, and metals like to lose electrons. When they lose electrons, they form positive ions called cations. On the other hand, you have the group 5, 6, and 7. So these are the nonmetals. The nonmetals like to gain electrons. So they like to gain electrons. They will form negative ions. However, they only form ions if their partner, if basically the things that bond together are metal and nonmetals, only then they form ions. If you have nonmetals and nonmetals together, then you will get covalent compounds. So you get covalent bond, meaning covalent compound has covalent bond. These are between nonmetals and nonmetals. So ultimately, we are looking at combining power of the elements, okay, and not just the charge of the ions, but of the elements. How do they like to combine? They can combine as ions, or they can combine as atoms between the nonmetals to give you covalent bond, that is sharing of electrons. So if we look at group 1 metals, so group 1 metals have a valency of 1 because they have one electron in the outer shell to be lost, so that you can get things like Li plus, Na plus, and K plus. Metal lose electrons and form positive ions. Metal still, group 2 will form the plus 2 metal cations. So these are still 2. Aluminium, a metal in group 3, has a valency of 3 because what you will get is you will get Al3 plus. These are from your bonding work 1. Okay, many weeks ago, aluminium loses 3 outer shell electrons, give you Al3 plus. Onto the nonmetals, things like carbon, which are in the middle of periodic table, they don't really want to gain 4 electrons. Instead, they actually share 4 electrons. As you remember from the last lecture tutorials, you talk about CH4, you talk about CO2, the carbon there form 4 covalent bonds. You can look at page 1 of your lesson notes, or you can go back to lesson part 1 of this series of videos. So that is going to be valency of 4 because it wants to share 4 electrons to go up to completely fill out the shell. So the objective is still the same thing. The objective is to fully fill the valence shell. So the metal will do that by losing electrons. The nonmetals like to do that, well, they can do it by gaining electrons, or they can share their electrons between nonmetal and nonmetal, which is what carbon likes to do. It shares 4 electrons because it has 4 outer shell electrons. Carbon is 2, 4. From your periodic table, when you draw second shell element, second period elements, group 4, group IV means 4 electrons outer shell, share 4 electrons, complete outer shell. Nitrogen, 2, 5, group 5, share 3 electrons, complete outer shell. Now group 6, oxygen and sulfur, if I look at oxygen, 2, 6, want to share 2 electrons to complete your outer shell, or you can also imagine as oxygen will want to gain 2 electrons to give you O2 minus ions. Of course, we are just looking at ions if our partner is a metal, okay? So ionic bonds, you have ions only when it's between metal and non-metal. If it is between non-metal and non-metal, like oxygen molecule, which was from the last lecture tutorial, and also from a covalent bonding topic, non-metal, they share 2 electrons with each other to give you 2 covalent bond there. Then you can get F2, Cl2, but you can also get F minus, Cl minus. These are ions, these are atoms. Oops, what am I doing? These are ions, these are atoms, so you need to be careful between the difference of these two, but the valency of group 7 elements will be 1. There are some transition metallic elements. Transition metallic elements basically look at the middle block of the periodic table. So if you think about the group 2 and group 3, they're separated by this huge chunk in the middle of your periodic table, which I've already given you as part of the notes. And yeah, I mean, you will have that middle block. Those are called transition elements. So those are equal to transition elements, and all of them are metals. You could also call them transition metals or transition elements, or you could call them transition metallic elements. Variable means can change, it's not fixed. Vary is the English word for change. It means it is not fixed at all. This is copper 2, you pronounce this as copper 2. It means you have copper 2 plus ion, and therefore the valency follows the charge of the ion. Iron 3, the charge is 3 plus, so the valency follows the charge of the ion, which is plus 3. Lead 4, lead is actually not a transition metal. It's in group 4 of your periodic table, below carbon, below silicon, below germanium, below tin. Okay, so it's going to be Pb4 plus. That's why it's a valency, is the charge of that ion there. And last but not least, you have manganese. Manganese there is going to be the Mn6 plus, so it's going to be 6 following the charge of the ion there. So the valency of these things follow the Roman numeral as a result of the charge of the ion, as per the definition, one of the definition given, although I've given you another definition there as well. Now we have this valency of polyatomic ions. Poly means many. Atomic means you have many atoms. This is problematic because these are never ever given in the periodic table. Never ever given in the periodic table. This so happens to be one of the many things that a lot of students will not be able to get, but they like to ask you in exam. So make sure you can master it. This is called ammonium ion. Ammonium ion is NH4 plus. The way you pronounce it is NH4 plus. So what does this mean? This means 1 nitrogen, 4 hydrogen. Be very careful. The charge is plus 1. The charge is plus 1. Remember, valency is the charge that the ion would carry. So the valency of ammonium, which is an ion, do not confuse this with something else, which is called ammonia molecule. Ammonia molecule come from your covalent bonding topic, where the nitrogen will share 3 out of 5 of its outer shell electrons, so that your nitrogen still have 2 more electrons that it hasn't shared with the hydrogen, because your nitrogen is from second period, second shell, first shell, second shell. This is group 5, so it's got 5 valence electrons. 1, 2, 3, 4, 5. It uses 3 for bonding. 1, 2, and 3. These are covalent bond. That's why these are molecule. Okay, so covalent molecule there, ammonia, but ammonium ion has a charge because this is an ion. So be careful the spelling. You can never ever confuse between molecule and ion, just like you could never ever spell this versus this incorrectly. This thing, you have to memorize it and make sure that the next time you say NH4 plus, you mean it is for ammonium. When someone asks you ammonium, you must know it as NH4 plus. Next one up is something called nitrate ion, NO3 minus, and then this is OH minus, this is CO3 2 minus, and last but not least is SO4 2 minus. There are 5 things there altogether, and none of these you can ever forget because these are things that the Cambridge examiners really expect you to be able to do. These are the hardest bits in chemical formula. Once you can get over these, no one can ever trick you. Okay, polyatomic, more than 1 atoms. There's 1 nitrogen because there's no number there. 1 nitrogen, 3 oxygen, minus 1 is the charge, so the valency is 1 there, follow the charge. Hydroxide is also an ion, 1 oxygen, 1 hydrogen, minus 1 charge, the valency is 1. Carbonate, C, there's 1, oxygen, there's 3, the charge is 2 minus. Because the charge is 2 minus, then you have 2 being the valency, which follows the charge, CO3 2 minus. If you remember the ion, then you know the valency. SO4 2 minus. So all these numbers look confusing. These numbers are the same, but the charges are not the same. These numbers are different, but the charges are the same. Until you can get this right, you can't really do chemistry properly, not even for the combined science. So you really must be able to get these, all 5 of these correct. What I advise you to do is practice the spelling, and then next to it, practice writing down the formula. Make sure you know the charge first of all. NH4 plus 1, NO3 minus 1, OH minus 1, CO3 2 minus, SO4 2 minus. Make sure just we are writing, you are also speaking out, you're also pronouncing it. Nitrate, NO3 minus, carbonate, CO3 2 minus, hydroxide, OH minus, sulfate, SO4 2 minus, ammonium, NH4 plus. Until you can do all these naturally, which there are only 5 examples, so you must spend time on getting them correct and never again ever getting them wrong in the future. Now I'll just show you these methods as outlined here, how to get the chemical formula. These are valency for the sodium and also for the oxygen. So what happened then is, if I show you another page of paper, it will make more sense. Okay, so this lesson has gone far long enough, but let me just finish it off with these, and then we can continue the rest next time. So we have Na2O, and then what's the next example? I don't actually want that to be there. I want the blank page to go below it. Anyway, so we have Na2O, we have MgCO3, AlOH3. So if I just copy that first, MgCO3, we also have AlOH3, and last but not least, the example there is PbO2. Okay, so I'll just very quickly show you before I end this tutorial on how to get this particular thing. You can refer to your notes. On what are the steps. So I write down sodium, Na plus and O2 minus. Na plus because metal lose 1 electrons there, form plus 1 because it's a group 1 metal. The valency is 1. The valency there is 2. So you cross multiply the valency because the 2 is the number there. So bring down the 2. The 1 is the number there from the charge. So bring down the number. So this is the number. What does number means? The number means there are 2. 2 of what? 2 of this thing on the left hand side. So there's Na plus 1, Na plus 2. And then this O2 minus, there's only 1 of it. So this and this is going to combine. How are they going to combine? 1 of Na plus, 2 of the Na plus, because 1 and 2, and then 1 of the O2 minus. Then the formula of this is called sodium oxide. Oxide because this ion, the name is called oxide ion. This thing is called sodium ion. When you combine them together, you just call it sodium oxide. This is a compound formed between a metal and a non-metal. This comes from a metal having lost an electron. This comes from a non-metal having gained 2 electrons. That's why you get 2 minus. Metal and non-metal, you get ionic bond, and therefore Na2O is an ionic compound, which means you have properties of ionic compounds as they appear in your topical test very recently, and also from your lessons on the properties of ionic compound, which you're supposed to go back to review from time to time. Next up, we have magnesium carbonate. So very clearly, magnesium is group 2, so it's Mg2 plus. Carbonate is one of the 5 polyatomic ion, CO3 2 minus. This is called carbonate ion, whereas the other thing is called magnesium ion. So the name of this thing is called magnesium carbonate. So make sure that you are building up your vocabulary. So the valency there is 2, following the charge on the cation. Following the charge on the negatively charged ion, called anion, is 2 there. When you cross multiply the number, and then surprisingly, the formula doesn't show a 2 or 2 there. That is because this thing is not the simplest ratio. You want the simplest ratio, it means you can divide by 2. Okay, so you can divide by 2 to get to the simplest ratio. What's going to happen then is 2 over 2 give you 1, 2 over 2 give you 1. So therefore, this means there's 1 Mg2 plus and 1 CO3 2 minus. So what you're going to get is Mg2 plus 1 of it, CO3 2 minus 1 of it. Naturally, they're going to give you MgCO3, which is the formula of magnesium carbonate. If you know the ions, then you can get the formula based on how they combine. How many of each do you have in the simplest ratio? This is to get simplest ratio. Okay, on to the next part. So we'll try and wrap this up very quickly as well, because we're running out of time. So anyway, I want to move this down a little bit, and I want to get it started as soon as I can. So what do we have? We have Al3 plus and OH minus. Our valency is 3 and minus, and 1. Following the charge, the number on the charge is 3, the number on the charge is 1. Cross multiply, then 1 will go to from here to here, aluminium, and the 3 will go from here to here, so you get 3. What does this mean? This means 1 Al3 plus. What does this mean? This means you have OH minus, OH minus, and OH minus. So altogether you have 3 oxygen and 3 hydrogen. So what this actually means is Al3 plus, bracket, 1 of it, OH minus, 3 of it. So I will write it as AlOH3. How do you read this? This is read as Al bracket OH3. Al bracket OH 3 times. Al bracket OH 3 times. What does this mean? There is 1 time Al, there is 3 time OH, meaning to say there's 3 time oxygen and 3 time hydrogen. The bracket there means 1 times 3 oxygen, 1 times 3 hydrogen. So be very careful about reading those things. All right, I'm just going to quickly add in another page because I run out of space for this thing, PbO2. PbO2 is the last example shown in the notes. So this is actually Pb4 plus and O2 minus, because this is what you call lead-4 as stated in the notes, and this is oxide ion. So this thing is called lead-4 oxide. Remember this thing, the 4 there represent the charge on the Pb4 plus. So what we can do is we can write down the valency of 4 following lead-4 oxide, 4 plus. So valency follow the charge, which is 4. Valency for the oxide ion, a group 6 anion, is going to be 2 following the charge of that. You're going to cross multiply. So the 2 from the oxygen will go to the left hand side. The 4 on the left hand side go to the right hand side. These are not the simplest ratio. I hope you know what simplest ratio in the context of mathematics means. It means you can simplify the number further. I can divide by 2 because this can be divided by 2, this can be divided by 2. So not always divided by 2, but depending on the situation. So that will give me one of these thing on the left, which is Pb4 plus, so 1 Pb4 plus, and 2 of that thing on the right, which is O2 minus and O2 minus. So what I'm going to get is Pb4 plus 1 of it and O2 minus 2 of it. So I get PbO2 as my formula for lead 4 oxide. I think I'll stop there for this lecture tutorial, and we'll continue more onto the other stuff in the notes in our next lecture tutorial. Thank you for watching. Don't forget to subscribe by clicking the button on the bottom right. Follow me at ptet.chemistry on Instagram, Facebook, and Twitter to get connected. Thank you for watching.